how to solve basic separable differential equations in the form of dy by dx is equal to a function of x times by another function of y. Now before I explain how to solve these equations, I want to make it clear that by function of x, I mean any function of x where f of x can have x's in there, or it could just be a constant such as 1, 2, 3, etc. G of y, on the other hand, can be 3 times y or any other function of y. However, it cannot be a constant such as 1 or 0. It has to have a y in there. Now to solve separable differential equations, you first have to divide both sides by 1 over g of y. So you have the y terms on one side with the dy by dx and the x terms on the other side. After that, you integrate both sides in terms of dx. So integrate the left hand side of the dx and the right hand side. Now after this, something funky happens. These two symbols here end up cancelling out in a way and just becoming dy. So you integrate one side by dy, which is f of y, so terms of y integrated by dy, which works as you know how to, and you integrate this side, f of x, in dx. After that, you solve and simplify for y of x. Now here's an example of separable differential equations. Here we have dy by dx is equal to y times by x. We're also given this extra bit of information that y at point 0 is equal to 2. We start off by dividing both sides by y. The second step is to integrate both sides in terms of x. Now notice that we have dy by dx times by dx. That's going to create a new symbol of y. And on this side, we're just going to integrate as normal. So now we have all the y terms on one side, divided by dy, and we have a half x squared plus c. To deriving the left hand side, we get the natural logarithm of y plus a constant, and is equal to our previous right hand side of the equation. Note here we have two constants. We can bring them both onto the right hand side and still treat them as a constant c, because it does not matter if we have 2c or any other number before that, because it's still a constant. So here it is. The equation is now the logarithm of y plus half x squared plus c. There's no 2. There's no need for a 2. Now we're going to raise both by e, so we're going to have e to the power of the natural logarithm of y, as well as e to the power of a half x squared plus c. Now here we're going to do a little trick, where we're actually going to have e to the half x squared times by e to the constant here. Because if you have the same base times together, you plus the powers as one of your index laws. And on the other side, we have one of the logarithmic laws, so e to the power of a natural logarithm, you just get this constant here. So there it is. Now we're going to write e to the power c as a new constant such as a, just for a bit neater, because e to the power of any number is just going to be another number, as both of them are constants. After this, we're going to remove the modulus lines. Because this is any constant, it does not matter if it's positive or negative. We're going to find that out later, so we can just remove those. After this, we're going to sub in our original equation up here. That is y is at 0, y is equal to 2, where x is 0. So here we go. So y is equal to a to the power e to the power of a half times by 0 squared, which is equal to 2. This shows, we'll move that up just a little bit, that a is equal to 2, and therefore that the final equation is y is equal to 2 times by e to the half x squared. And there you have it. To check your answer, you can always derive the equation and try to get back to the original equation up here. Thank you for watching. Make sure to like and subscribe, and I'll see you in my next video. See you later.